I wanted to do a follow-up example of these distance problems. I know I did one in the video lesson about a bus, and the bus driver was driving, had to go faster, how much faster it had to go, was the original rate, all that. I do another one here about a boat in the water, because I think these come up a fair amount too. So a boat, which moves at 18 miles per hour, this is number 13 in the textbook. So it travels at 18 miles an hour in still water. So that means that not going upstream or downstream, it's 18 miles an hour on Albertley Lake or something. Um, it goes 14 miles downstream, so it goes down the river 14 miles. And the same amount of time, it can travel 10 miles back upstream. So it can go further downstream in the same amount of time as it can go upstream because there's a stream and the current, the river has a current and pushes against it going back upstream and pushes it forward going downstream. So that current is going to play a role here. The question we're going to be asked to find is figuring out what is the speed of the current. So find the speed of the current. I'm going to go over to the document camera. Here it is. I just got a little note here to myself, 18 miles per hour is how fast the boat goes, 14 miles downstream, 10 miles upstream in the same amount of time. I'm going to make that table again. So I'm going to make my distance equals rate times time table. And the two things I'm comparing this time is upstream and downstream. Okay, so the two most important parts, the first important part is filling in this table here. So the distance it goes upstream is 10 miles upstream. So it goes 10 miles upstream. Downstream it goes 14 miles. So the distance 10, distance 14. The rate is 18 miles per hour. However, we have this current to contest with. I'm going to use X because I think that's what the text uses. Sometimes I use C for current, but I'll use X because that's what the textbook says. If you're going upstream, the current is working against you. The current is pushing back against the boat. And so we would have a rate of 18 miles an hour minus whatever that current is, because it's going to be going slower. Your rate of travel will be that 18 miles an hour, but the current is working against you, so you'll really be going slower. And the time, T, we don't know how. Going downstream, however, we have 18 miles an hour plus the current. The current is pushing forward, so we're actually going faster than 18 miles an hour in reality, even though the boat is working at the same work. Time, again, is the same, and that is important for this one. In this problem, the time is the same. It takes the same amount of time. So the time is going to be equal to each other. Sometimes we'll have to combine time together. It'll say a total time of 8 hours or a total time of 5 hours. We're going to be adding these things together. In this case, they're equal. All right. So we're going to use the idea or the concept that we could solve for t. So if distance equals rate times time, that means that distance divided by the rate equals the time. So solving for the variable t. So I'm going to do distance divided by rate. 10 divided by 18 minus x is upstream. Distance divided by rate. And I know that the two times are equal to each other. So I'm going to set them equal. Distance divided by rate for downstream would be 14 divided by 18 plus x. At this point, you have a choice. You could either get common denominators or you could cross multiply and work at it that way. I'm going to get common denominators. So I'm going to multiply by 18 plus x here. Remember to multiply the numerator and the denominator by the same thing. And multiply this side by 18 minus x. Again, that'll give me a common denominator here. Multiply the numerator and the denominator by the same thing. Since the denominators are equal to each other, the numerators must be equal to each other. So I'm going to effectively ignore the denominators. I'm going to say that if I distribute through the parentheses here, I'd get 180, 10 times 18, plus 10x, 10 times x, equals, distribute here as well. If I do 14 times 18, I'm going to get 252 minus 14x. Hey, no squareds. I don't have to solve for a quadratic in this case. Because again, the denominators are equivalent here, and so I don't have to worry about solving for x in the denominator. We know they're the same because it's the same factors. Okay, so if I add 14x to one side, I would get 24x. Add 14x to both sides of that equal sign. If I subtract 180 from both sides of that equal sign, I'm going to get 72. And then if I divide both sides by 24, I get that the current in the river is going to be 3 miles per hour. So that's how we can look at current. And what's the current in the river? Is the current, if you're going upstream, is working against you, minus. The current going downstream is working with you, plus. That's how you deal with that current. Once you get that table set up, that's the first hard part. Figuring out, do I set the two times equal to each other? Do I add the times together? What am I doing with those times? And then doing the algebra from there. Okay, hopefully that helps a little bit with those current ones. I can't guarantee that they're going to be easy, but if you have more questions, if you're unsure of a starting point, please email me, and I'll try and help you as best I can.